Are you done? What is A?
2.
2, right. What is B? 2. Okay. What is n power log A base B? Right. N log 2 base 2, which is 1. It is nothing but n. Now, what is Fn? N by log n.
Oh,
Yeah, n by log n. Now, which one is dominating? Which one is larger? N or n by log n? Obviously, n is larger. So, n power log A base B is greater than Fn. This is n by log n. This is n. So, which case? Case 1. But we can't apply case 1. Here we will define the formal definition. So far, we have discussed informal definition to solve this kind of reconciliation. That's why I said informally. When we say that one term is larger than another term, merely larger is not enough. That minute difference. In this case, n versus n by log n. Log n is very small term, right? So there is not significant difference between n versus n by log n. So when we say that one is larger than another one, the difference would be significant. Clear? Now we will define the formal definition to help you to understand the definition of that significant difference. What do I mean by significant difference? Clear? So in this case, we can't apply case 1 or Master Theorem because the difference between the left and right is not significant. Now, what does that mean? This is Master Theorem. So 1, 2, 3 are nothing but case 1, case 2, case 3 that we discussed. So if you go through that point 1, Fn equals to B go of n power log A base B, right? You are not familiar with epsilon. Just keep that right now. So what does that mean? Fn equals to B go of n log A base B. What does that mean? What is the relation between Fn versus n power log A base B? Who is larger? Okay. Fn versus, check the middle figure. Fn versus Gn. The middle figure is Fn equals to B go of Gn. Which one is larger? Fn or Gn? Gn, right? So in this case, Fn equals to B go of n power log A base B. Which one is larger? N power log A base B. So what we wrote, Fn is less than B go n power log A base B. That is the case 1, right? In our case, it is mathematical representation of that thing. Clear so far? So Fn equals to B go of n power log A base B. Then the solution would be, because the n power log A base B is larger, dominating part, so the solution would be Tn equals to theta n power log A base B. So you know that, right? Case 3 is just opposite. Fn equals to omega n power log A base B. So which one is dominating part? Fn, right? Omega, just opposite of B go. So if you check this, the last figure, figure C, Fn versus Gn, which one is larger? Fn, right? So case 3 is just opposite of case 1. If Fn is larger, then I'll discuss. If Fn is larger, then the solution will be theta Fn. You know that. And case 2, what is case 2? When both are equally dominating. That's why theta. Theta means they are almost equally same, almost. So when they are equally fast enough, then the solution would be n power log A base B multiplied by a very small term log n. So overall idea is clear to you? What we did informally, because we skipped couple of conditions. That's why I said it was the informal definition. We skip couple of conditions. Now we'll dig deeper into those conditions. So clear, right? Okay, we'll dig deeper into code case number 1 and case number 3. Okay. So the generic form is Tn equals to A Tn by B plus Fn. This is the generic form of the recurrence relation so that we can apply Master theorem. We basically comparing between these two terms, right? Fn versus this term, which one is dominating. So this is last day I said that this is same as n log A base B. Now, how do I get this term? Today, at the end of this class, we'll discuss that. Okay. So basically, we are comparing this one versus Fn. Now, which one is larger? That would be your answer. Now, what was case 1? In case 1, left greater than right. Case 3, right greater than left. Case 2, both are same. Very easy. So case 1, left is greater than right. So here left is n log A base B greater than Fn. Informally, if that is the case, then your solution would be Tn equals to theta. Which one is dominating? Left or right? In this case, left. So theta left. This is your answer. So here left is theta n log A base B. Informally. So this greater than, that left is greater than right. Is it enough? If their difference is very minute, is it okay? No, right? That means there should be a significant difference between them, right? So that is polynomically larger. So left should be polynomically larger than the right. Right? What does that mean? That means left is so large that n log A base B and Fn, the left is so large that if you divide the left by a polynomial term, it is still larger than your right. So it is so large. Did you get it? And epsilon is greater than 0 here. Okay? Are you with me? So polynomial term means, don't be confused with that. Here n epsilon is 1, that means n power 1, that is n. If it is 2, it is n squared. If it is 3, it is n cube. It is 4, n4. You are familiar with this term, right? So those are polynomial term, that is n power k. K is some variable. That is polynomial term. So how can I write it using an asymptotic notation right now? So this is same as Fn is less than this part. This is same, right? Now, how can you use asymptotic notation to represent it? When Fn equals to big of Gn, which one is larger, Fn or Gn? Which one is larger? Gn, very good. Gn is larger. That means this part is larger. So how can you write the same thing for this relation? Which one is larger? Right. So we can write Fn like this way. Big of this part, right part. Right? So it is same as big of n log A base B minus epsilon. This same, right? So this is the relation. What this relation is saying? It is saying Fn is smaller than this value n power log A base B, and that difference is also polynomically lower. That's why minus epsilon. So we describe this using words, and this is the same representation using asymptotic notation. So this is case 1, right? So if that is the case, then what would be the solution? If case 1 is applicable, then what would be the solution? So this part is larger, right? So that is the solution. Now case 2, when both are equally dominating. So n power log A base B and Fn, both, you may think both are equally dominating, almost equal. So if that is the case, then what will be the solution? Yeah, right. Just apply your intuition. So this is multiplied by a very small term, log. Yeah, that is the solution. Now, why I am multiplying by a small term log n, we'll discuss at the end of this class, when we'll prove this theorem, a basic proof, so that you can get the high level picture. Okay. So this is case 2. Now case 3. Case 3 is almost opposite, reverse of case 1. So you are comparing again. Which one is larger in case of case 3? Fn, yeah, right. So Fn is larger. Now, how large? Is it enough that their difference is very minute? Will it be enough? No. Similar to case 1, it should be polynomically larger. So how to represent that? What does that mean? Polynomically larger. So I'm saying right side is polynomically larger than left side. What does that mean? Similar to case 1. So Fn is so large that if you divide it by a polynomial term, still it is larger than left. In other words, you can multiply this term with this one. It is same. What do you think? It is same, right? So if we multiplied it with the left term, still Fn is larger than that part. That means Fn is greater than n power log a base b multiplied by n epsilon, right? So similarly, we can write the right part is like this way, plus epsilon. Clear? So Fn. Now, how can you represent it using asymptotic notation? So we know Fn equals to big omega Gn. So which one is larger? Which one is larger, Fn or Gn? Fn, just opposite of case 1, just opposite of big O. So Fn is larger, right? It means Fn is greater than Gn. So similarly, how can you write this relation using asymptotic notation? Big omega of n log a base b plus epsilon. So this is actually saying the same thing, which we are describing using words, that Fn is larger than this part, and it is polynomically larger. How do I know polynomically? Because of this plus epsilon. It is telling me that it is polynomically larger. Clear? So if that is the case, that is case 3, then the solution would be Tn equals to, what will be the solution? Which one is dominating? F of n. So answer will be theta of Fn. Now, case 3, we are not done yet. Before coming up with this solution, we also need to check one condition. What is that condition? That is called regularity condition. So you need to check whether regularity condition is satisfied or not. Then you can apply case 3. So what is regularity condition? It is saying that this is the regularity condition. Now what? C is a constant, C is less than 1. What does that mean? It means, so how you divide the problem? Initial problem is of size n. You divide into multiple sub-problems. So how many sub-problems are there? You know that. A, T, n by B plus Fn. Which variable represents number of sub-problems? A. So number of sub-problem is A. I don't know the value of A. In case of binary search, it is 1. In case of merge sort, it is 2. I don't know the value of A. So A number of sub-problems. So number of sub-problems is A. And each sub-problem, what will be the size of each sub-problem? N over B. So each sub-problem is of size n by B. Clear so far? So n, suppose the time I am spending is Fn, and it will be further divided into smaller subproblems, f of n by b, f of n by b. And how many subproblems are there? A number of subproblems. So at this level, you know tree, right? So at this root level, how much time I'm spending? Fn. This is the total amount of time I'm spending, Fn. Now tell me at this level, how much time we are spending? You are close to that, multiplied by of n by b. Did you get it? Clear? So what the regularity condition is saying? A multiplied by f of n by b. So the left part. What is the left part actually? What it represents, the left part. So this is the time, the left part is saying that this is the time you need to spend at the lower level. That should be less than equals to C multiplied by Fn. What is Fn represents here? The time you spend at the upper level. The time you spend at this upper level. So at the upper level, you are spending f of n time. At the lower level, you are spending a multiplied by f of n by b time. And it is saying that Fn, upper level, you are spending more time compared to the lower level. So at the upper level, you are spending more time compared to the lower level. Even you are multiplying by a value c, and c is less than 1. That means in the upper level, that amount of time you are spending, if you take the fraction of that time, it is still less than greater equals to your lower level time. Did you get it? Do I repeat it? Okay, don't worry. So regularity condition is A multiplied by f of n by b less than c of f of n, where c is less than 1. Now, Fn is the amount of time that I'm spending at the root level. It would be further divided into multiple subproblems. I don't know how many. It is a number of subproblems. Clear? For each subproblem, I need to spend f of n by b for each one. F of n by b. Clear so far? So tell me, at this level, I am spending this amount of time, f of n. At this level, you have a number of subproblems, and for each subproblem, you need to spend f of n by b time. So how much total time you need to spend at this level? For each subproblem, you need to spend f of n by b. And total number of subproblems are there, a. So what would be the total amount of time? Yeah, right. A times f of n by b. Because this is for each subproblem. So total would be a multiplied by this one. You got it? So this is the amount of time you are spending at the lower level, where Fn is the amount of time you are spending at the upper level. So what this equation is saying? It is saying that at the upper level, it should be greater equals to the time you spend at the lower level. So at this level, you will spend more time compared to the lower level. Clear? So here C is a fraction, C less than 1. That means at the upper level, if we take fraction of that time, it is still greater equals to the lower level time. So if regularity condition holds, then you can apply case 3, and the solution would be the dominating part Fn. So the solution would be this one, Tn equals to theta f of. So let's practice a couple of them just for revision. So Tn equals to okay. So first do this one. To find out what is A, then what is B, then what is n power log A base B, what is Fn, and then compare n power log A base B versus Fn. A fixed step that you need to follow. Solve together. What is A? 9. Okay. What is b? 3. Very good. What is n power log a base b? What would be the value? N square. N square. So 9 is 3 square, right? Log 3 base 3 is 1. What is fn? N. Which one? Now you need to compare these two terms. This is n square. This is n. Which one is dominating? N square is dominating. So which case will be applicable? Case 1. Very good. Even you can check whether it's a polynomically larger or not. What does that mean? If you divide the left part by a polynomial term for a particular value of epsilon, it should be still larger than right part. So you can divide it like a very small term like 0.5, because epsilon should be greater than 0. So still it is n 1.5, which is greater than n, right? So you can find such epsilon value. You need to find one value, one such value. So it is polynomically larger. That means case 1 can be applicable. If case 1 is applicable, what is the solution? What is the solution? Yeah, actually n power log a base b, it is nothing but theta n square. Clear? Great. Now the second one is pretty similar. I will only change fn, the value of fn. Now it is n square. Now tell me what will be the answer. You already calculated n log a b, so n log a base b. You know that is n square. Here fn is also n square. So which case will be applicable? Yes. Case 2. Very good. So case 2, that is they are equal. So what will be the answer? N square times log n. Clear? Very easy. Now third one, I'll change only fn. So you already know n log a base b is n square, and fn equals to n cube. Now which one is which case will be applicable? 3, right? Case 3 will be applicable. You can also check the polynomially larger or not, regularity condition, all will be hold here. So okay, case 3 will be applicable. So what will be the answer? What will be the answer? N cube, right? N cube is larger, so answer is theta n cube.